right. So good afternoon. Welcome to our CeTaQ America's first webinar series on addressing critical to quality subjects in SMT. Today the webinar is titled Working with Solder Paste Tips for Success, where we're going to look at solder paste performance from a process engineer's perspective. Next, right? So please ensure your microphones are muted to avoid cross noise and distraction, and ask any questions in the group chat, and we will pause to answer them. Following the webinar, we'll be sending out a brief survey via email and ask you to complete them as it helps us improve. Next. And about CeTaQ, we want to introduce you to our company, founded in 1996 in Dresden, Germany by Matthias Keil and Heiko Haupt. They, in their thesis work, did find a way to measure machine capability and have been developing tools and such since then. But CeTaQ is an independent machine capability analysis company, providing metrology-based measurement services and equipment to European and Asian customers, including OEMs and end users of SMT equipment. It allows OEMs and users to characterize, optimize, and understand their equipment's performance in terms of accuracy, repeatability, and stability. CeTaQ Americas was established in 2001 by myself, Michael Savigny, to provide the same services and equipment to North, Central, and South America-based OEMs and end-user customers. In 2023, CeTaQ expanded our portfolio of seasoned services to include process consulting, IPC certification, and process training to customers who want to ensure their people, their process, and their equipment are all operating at their optimum potential. Being CeTaQ certified is an indication to your staff and customers that you understand the importance of people, process, and equipment as a function of quality, efficiency, and customer satisfaction. Next. With that in mind, CeTaQ Americas has adopted a philosophy that ties together the concept of PPE, with the underlying message: if you don't manage your people, process, and equipment, then you don't maximize your profitability. Because if you don't train, you don't succeed. If you don't optimize, you don't perform. And if you don't measure, you don't know. Next. And based on that philosophy, CeTaQ Americas is launching our critical to quality webinar series for process engineers, technicians, and those that support day-to-day operations in SMT. And we want to break down the challenges in SMT, discuss potential causes and what you can do to improve the manufacturing process, adding more tools to your troubleshooting toolbox. And next. The presenter today is Ray Lawrence, a 27-year veteran of the industry as a senior process engineer, working for different companies, automotive and consumer and EMS. And he has a certified SMT process engineer, certified IPC trainer in the Lean Six Sigma Green Belt, current president of the Carolinas chapter of SMTA. He received his associate and bachelor's degree in manufacturing engineering technologies from both Edinburgh University of Pennsylvania and Rochester Institute of Technology, where he was first introduced to electronics manufacturing. He joined CeTaQ Americas in 2023 as a technical manager and their lead trainer and consultant, where he works with companies to support the PPE philosophy and helps develop the next generation of SMT process engineers. So thank you very much, and Ray will get started.
Okay, thank you everybody for joining us on today's webinar on working with solder paste. We will be covering future topics such as printer cooling, stencil design, placement, reflow profiling, and more, so stay tuned for that. Additionally, if you have any topics that you would like to see us address, please go to our website, www.cetaq-americas.com, and let us know. The first thing we'll be discussing in today's webinar is solder paste deposition in SMT and the expectations for performance. When we talk about solder in SMT, there are four main methods that we can use to apply solder to a PCB. The first and most widely used in the industry is solder paste printing, which uses a stencil of a certain thickness with apertures or windows cut into the stencil, and a squeegee to push or print the paste into the apertures, depositing a fixed amount of solder paste on every pad. Another popular method is hand soldering, though hand soldering is not something that just anyone can do. It takes a good fundamental understanding of heat, both in time and temperature, how flux and solder are used and interact, as well as attention to detail, patience, and a steady hand. And for those of you who want or need to learn more about hand soldering, we do offer on-site hand solder training for both SMT and through-hole, for folks to learn the basics, develop the techniques, and to prepare to obtain your J Standard 001 certifications, which we also offer as an on-site class. So if you're interested with that, please let us know. Getting back to deposition, the third commonly used method is by dispensing. Dispensers can use air or pneumatics, auger valves, or various other methods in conjunction with nozzles to control the amount and rate that is dispensed on the pads. They can be manually operated, such as a small pneumatic hand solder dispenser, or can be put in line as a machine positioned after the stencil printer. Paste dispensing can also be installed in some stencil printers or inside some solder paste inspection machines to either add volume that the stencil cannot provide or to fix insufficient issues real time. Solder paste jetting is another process where the equipment can be programmed to build up solder deposits using a high-speed dispense head and multiple passes, kind of like 3D printing, but with solder paste. Jetting is used to augment the printing process, to add paste volume, but it is also capable of replacing the printer and the stencil altogether in some applications. It's used to completely print the board. It's fully programmable and can fine-tune dispense volumes and shapes as needed down to the smallest deposit that is not possible with stencil printing at this time. One caveat of jet printing is that finer solder pastes are usually needed, which come with their own set of process challenges, and they need to be compatible with the paste that you already have printed on the board. In solder paste deposition, accuracy and consistency of every deposit is key. If your print or your deposit is not repeatable and is not accurately aligned to the pads, defects will occur. Applying solder paste in SMT can also allow you in some cases to eliminate downstream hand wave and selective solder applications and be able to install and reflow through-hole components in SMT, called pin and paste or intrusive reflow. Higher volumes of solder paste are needed to provide the acceptable form solder joints on those plated through-hole leads. Now, implementing pin and paste or intrusive reflow can eliminate downstream soldering, which can save you time, money, and speed up the assembly process. But there are many considerations and caveats to consider before you commit to this process. We'll be looking at pin and paste in a future webinar, so please stay tuned for that as well. With fully automated screen printers used in SMT stencil printing, keep in mind that they will lose their capability to be consistent over time. This is due to normal wear and tear, mechanical failures and repairs, lack of maintenance, and also machine crashes. Since the print operation is the source of the majority of your defects on an SMT line, it's important to maintain strict quality standards as well as a thorough understanding of your machine's capability to maintain its alignment accuracy and its print repeatability. This helps uncover mechanical issues that may not be evident or obvious, and you can implement corrections, which will eliminate variation and process shifts. There's been a study conducted that shows approximately 80 to 90% of stencil printers that are used on the manufacturing floor will begin to fail in maintaining their machine specifications in around 8 to 9 months of use. Regardless of how you apply solder and SMT, the end goal is to provide the amount of volume of solder combined with a good placement and reflow process to create a robust solder joint. Every solder joint needs to meet or exceed the requirements of the customer, as well as IPC A610 acceptability requirements. Fillet form, shape, volume, and the interconnection to the lead surfaces and the pads need to meet specification. Failure to do so will reduce the life expectancy of the product and cause the product to fail. Before we continue, do we have any questions of what we've covered so far?
Ray, I don't have anybody in the chat box right now, but I'm going to send a message just to highlight where.
Okay. While you're doing that, I'm going to continue.
Yep, good.
So what are some of the solder paste keys to success? Well, first of all, let's establish what solder paste is. It's a mixture of metal solder balls or powder with flux and other additives that will determine its performance. We're going to be using the generic term of flux to describe both the flux and additives combined in this discussion. We're not going to get into in-depth on the solder chemistry formulations or solder ball size or alloy makeups today. But what we do need to know is that solder paste must maintain a homogeneous or uniform mixture, which means there's no separation between the flux and the solder powder, as the flux is what holds everything together. Typical solder pastes used in manufacturing today are either water wash or no cleans, lead or lead-free, usually a type 3 or 4. But all paste should have the consistency of about like toothpaste. There's higher types with smaller ball size that are used for dispensing and jetting. Now, when paste is moved, such as in stencil printing, the viscosity of the paste will change through a process called shear thinning. And this allows the paste to be pushed by the blade and roll across the stencil. Now, this rolling action is critical to getting a good deposit because the roll and the reduction of the viscosity allows the paste to fill all the apertures. So if you're not rolling, you're going to get defects. Once the paste is deposited and the shear thinning action is over, the paste will start to recover its thicker viscosity. In the case of stencil printing, when the stencil is removed, the paste will hopefully release from the stencil as completely as possible, termed transfer efficiency, and remain on the board in a brick-style shape. The flux is critical to facilitate printing and is critical for placement and reflow as well. After the flux is sufficiently heated, it cleans the surfaces to be joined of oxides. It also prevents oxides from reforming during reflow and helps the molten solder flow and wet to the surfaces to create the solder joint. What is left is flux residues. These residues either need to be removed from the assembly through a cleaning process, or in the case of a true no-clean process, they can be left on the board. Leaving flux on the assembly can impact not only downstream processes, but it can also affect the reliability of the assembly in harsh working environments. Now, if you're using a water-soluble or water wash flux, and it is left on the assembly and not properly cleaned off, it will remain active and corrode the assembly over time, causing failure. No clean fluxes, on the other hand, provided that they have been properly heated, will leave residues whose activity level is very low and will likely not have a detrimental impact on the life of the product. But that will depend on the working environment and the functionality requirements of the assembly. If flux is not properly heated, like in hand solder, and you're using a little bit too much liquid flux, that liquid flux remains active and could corrode the assembly over time if not removed. No clean fluxes that do need to be removed but have not been properly removed will interact with the working environment and may eventually cause the assembly to fail. When humidity and electrical bias is applied over time, flux residues can create an environment for what is called dendritic growth, which is shown in this picture on the right in black and white. Dendrites are conductive, and it may eventually connect two non-common conductors, which will result in electrical short and the unit will fail. There are some other issues that flux residues can cause. They may hinder visual inspections. They might appear like fine solder bridges under inspection lighting, causing false calls, and that may mask bridges, actual bridges in inspection. We call this the cry wolf syndrome, where so many non-issues are called out repeatedly that real defects are missed. Flux trapped under parts or unable to escape solder during reflow will form voids. Some people call it bubbles, and it may impact the integrity of the joint. It may impact the thermal transferability or the signal integrity of that solder joint. Now, no clean fluxes, if they're left on the board and are on contact surfaces, can impact testability. ICT test probes or contacts could build up with flux residues, and it causes contact failures and false fails. When you're working with adhesives, encapsulants, and coatings, they also need to be compatible with your flux, or else they won't adhere or protect your product sufficiently. Now, you can conformally coat over no clean, which is commonly done. That saves time, money, and process development. But it is recommended to remove all the flux residue before you conformally coat, because if it is not fully activated or removed, you can still have corrosive or adhesion issues, as well as it can allow dendrites to grow, which would be impacting the long-term reliability of the product. Now, concerning site cleaning of fluxes, here's a little public service announcement. IPA is not a proper flux cleaner. I know it's cheap and we have gallons of it around the storerooms, but it will not remove fluxes. It'll just move flux around, and it may push active flux under parts. Some flux residues will also react with IPA, causing a white snow-like residue appearance, such as the center picture shown on the slide. Flux removers are engineered to break down the residues better, but it will also move flux around and not deactivate active fluxes. So the product needs to be sufficiently rinsed or flushed off to be truly clean when we're using flux removers. And if you do use flux removers, make sure they're compatible with the fluxes you do use, as well as your labels and your people, because some of them have a pretty strong smell to them. If the solder paste and flux action is not capable of creating a robust solder joint, it can cause premature failure. And it's just a matter of time when. And this is why IPC has its class structures to determine the quality. Besides the class 1, 2, and 3, more stringent requirements are included in their space addendum, because the danger of a failed solder joint on a plane or satellite or a rocket, it can be massively expensive, destructive, and even deadly. Elon just lost a spaceship just the other week. So what key solder paste characteristics do we need to look for that are critical to its function? First and foremost, it must be printable. What printable means is that it maintains its performance to fill the apertures and repeatedly be printed or used for an extended period of time. If it does not fill the apertures or sticks in the apertures of the stencil because of a viscosity issue, you will have defects and get insufficient solders. If it fails to hold its shape after printing, it will slump and cause things such as wet bridges. The second key performance is the post-deposit solder performance. Paste deposits may pass initial SPI inspections, but slump during the time between it's deposited and actually reflowed, causing bridges, especially when there's an extended time between deposition and reflow. And this is what we call cold slump. Now, if the paste is not tacky enough during placement, parts can become skewed or tossed as it won't hold them in place, especially during rapid transports and stops with larger mass parts. Paste may also start to slump excessively in the initial phases of reflow in the preheat sections. This can cause bridges in reflow, or in the case of pin and paste or intrusive reflow, allow the paste to fall out of the barrels or off the pins, reducing its final volume. This is what is called hot slump. So if you look at this image on the copper, you can see where we printed paste in a series of lines that get closer and closer together, reducing the pitch. The picture below it shows the paste after it was heated at 120 degrees as in preheating of reflow, and you can see the paste has slumped and has bridged together. If flux is exhausted prematurely, it may not be able to clean the oxidation and prevent it from reforming on surfaces. These joints may be rough in texture, which is called graping, and you may also get opens, non-wets, and insufficient joints. The picture of the resistor here shows graping as well as a non-wet condition. Also, if flux is compromised by moisture, it can cause solder balls or solder spatter, which is little solder balls out on the mask of the parts and the board. So if solder paste performance is not sufficient and joint requirements are not met, it can be a costly failure, especially if it's not detected. And with the speeds of SMT equipment getting faster and faster throughput ratings, a lot of defective product can be created very quickly. And that's can result in costly repairs, lost time, lost money, and lost customers. So how can you tell if your solder paste is the problem? Well, you can just start to look at it. Does the flux have flux separation between the flux and the solder? This may have resulted from being overheated. Check to see if there's moisture in the paste in the jar, because paste will absorb moisture. Does the paste look overly wet and shiny or dull and chunky when you compare it to other lots of paste or fresh paste? Stencil life may have been exceeded, or the environment may not be suitable for printing. Now, when you are printing, look at the way the solder falls off the blades between prints. Does it stick to the blade, robbing the next stroke of the needed paste volume, or is it runny and slops off the blade? Remember, paste needs to be the consistency of like toothpaste. As you're printing, look at the roll for a smooth surface. First, you got to make sure it does roll instead of sliding across the stencil, but also see if it has tears or pot marks in the roll as it prints. This could be an indication that your paste is breaking down. And immediately after printing, are your paste edges of the deposits uneven, or does the paste look like a brick or a blob? Now, keep in mind that print definition can also be a support issue or a gasket issue or a cleaning issue, but you can't rule out the paste if those other criteria have been met. After you print, check to see if your paste is holding its shape when it sits over a period of time, or does it slump. Check to see if your parts are being placed correctly in the machine but are shifting after transfer. This could be an indication that there's no tack left in your paste to hold the parts. Also, if you are getting pre-reflow bridges that weren't detected by your solder paste inspection, this may be an indication of paste slump. Now, after reflow, look at your solder joints. Do they have good wetting angles, a nice smooth fillet surface, or is it bumpy? This is an indication that your flux may be exhausted. If you have solder balls or solder splatter around or on the joints, this may be caused by moisture absorption in the paste. And if you are bridging after reflow but not before, this may be an indication of hot slump. Now, when solder is, check to see if the solder flows out and covers the pads when the apertures are reduced, or the solder is window pane, or does it stay in place? Solder should be expected to flow or wet out to the pads, with the exception of OSP board coatings. And what OSP is organic solderability preservative. What it is essentially a clear coat over the copper pads. And the main drawback of this board finish is that it becomes harder to break down and solder to the more heat cycles it sees. You can also test your solder viscosity using a viscometer. And if it fails, you're going to want to check the rest of the lot to see if the entire lot's been compromised. Check the temperature of the paste in the printer. It may be getting overly warm or is too cold to use. And with SPI, check your area and your height results. Is the area greater than 100%? Let the print sit for 10 minutes and then remeasure it. Let it sit for another 10 minutes and remeasure it again. See if your measurements changed. This could be an indication of cold slump in your paste. Now, if you determine that your paste is not performing as it is expected to, we're going to look at what are the potential causes and some things that can be done to prevent this from reoccurring. So before we continue, do we have any questions, Mike, in the chat?
Nothing at the moment in the chat.
Okay, great. So what could be the potential causes, and what do we need to look at, and what corrections should be made to prevent it? Number one, temperature changes during transport or handling. We may have had issues with paste delivery or the receiving of the paste, allowing the paste to warm up excessively. Because see, paste is shipped in cold packs and in coolers to prevent it from warming, but they only last so long. So did the paste sit on the loading dock all weekend before it was received? A process needs to be established to prioritize receiving of the paste and transferring it to the cold storage immediately. Now, paste should not be taken into cold storage if it has already been warmed, because condensation and moisture absorption, as well as flux breakdown, can occur. You also need to look at what kind of cold storage are you using for your solder paste. Dorm fridges and other consumer refrigerators can allow for huge swings in temperature and condensation to form. The recommendation is to use a paste storage unit that is made to store solder paste and have it continuously monitored for temperature to make sure it maintains the specification. Now, when you're pulling paste out of cold storage, does production just grab whatever is easiest to grab? Using a FIFO process, first in, first out, and auditing expiration dates routinely will prevent paste from being used after it has expired. And do you maintain a volume of supply that exceeds your production consumption? This needs to be monitored, and your purchase volumes may need to be adjusted time to time so you don't have too much paste on hand and can't use it quick enough. Other potential root causes: insufficient warm up time out of the cold storage. You need to make sure it sits for at least 2 hours before you use it. It also may be a good idea to verify your paste temperature before you release it to production use. And also, when you're warming it up, allow it to naturally warm up. Do not apply external heat sources. If you are in a crunch, you can place the container in a sealed bag and place it in a bath of room temperature water, and that can speed up the warm up process gradually. Paste mixers, which some people use, those will also impart heat into the paste due to the friction of the moving paste inside the container. So you got to be aware not to overmix it to prevent that overheating or the breakdown of the flux. And don't use the mixer with cold paste to warm it up. This can also degrade the flux prematurely. A more cost-effective and safer approach is to hand mix the paste in a jar for about 1 minute with a plastic spatula before putting it on the screen printer. And you never want to use a metal spatula. Reason for this is because it could shave off microplastics of the container and contaminate your paste. Cartridges, if you use paste in cartridges, those typically do not need mix because they are typically more stable than jars in the storage, but you do want to make sure you store them tip down. And when you put paste on the stencil, you're going to want to perform a paste knead on the printer before production as well as after pauses to production. It helps even out the paste across the blade surface, and it also gets the paste to an optimum working viscosity. Now, one trick when you're using paste knead is to use an adhesive-backed mylar to cover a board before kneading. This will protect the board and make it easier to wipe off that solder paste without embedding it in all the nooks and crannies on the board. And when the knead board is no longer needed, it can be easily removed, allowing that board to be printed in production without having to wash it first. And always keep in mind the stencil life of the paste. Stencil life is the amount of time that that paste will maintain its performance when exposed to the environment and when it's sitting on the stencil. Because solder paste will absorb moisture over time, as well as the solvents will evaporate. So keep the paste protected when it's not in use. Replace your plungers and push out the air to minimize air exposure in the jar of paste. And either remove the paste off the stencil during long pauses or use a saran wrap type material to protect the paste from the environment. Now, the environment inside the printer will directly impact the stencil life and the performance of the paste. Moving air over the paste will speed up the solvent evaporation rate. And you do need to monitor the temperature and the humidity inside your printers. A failing exhaust cooling fan for the electronics that are in the printer can raise the temperature inside the print environment excessively. You can use air conditioners and dehumidifiers attached to the printer to help maintain internal environments, but properly maintaining the filters and the moisture jugs is key, because a dirty filter can turn an air conditioner into a blow dryer and ruin your paste. Also, it's not recommended to run with the front door of your screen printer interlocked bypassed and the door open, because this can expose the solder paste to external environmental conditions, and not to mention you have moving parts, so you can risk injury. The proximity of the screen printer to external access doors, warehouse, shipping and receiving doors can cause significant swings in your humidity and temperature exposure inside your screen printer. So during the wintertime or periods of dry air in your factory, use humidifiers to put moisture back into the air so the paste doesn't dry out prematurely. Now, there is always the chance that the batch of paste that you got was compromised from the supplier, even though it's pretty rare nowadays. But having different manufacturing sites of the paste as well as seasons can impact paste during the initial manufacturing process if those environmental controls at the supplier site are insufficient. Lastly, production handling. Maybe the on-floor handling practices are insufficient to protect the paste. There should be enough paste at room temperature to support production without waste. So make sure you're using a FIFO process on the floor as well. There should be a system in place in your factory to identify when the paste was removed from cold storage, when it is ready for use after warming up to room temperature, and when it expires. And do not put warmed paste back in cold storage, or it does risk condensation inside the paste. And when you're done using the paste, provided the paste is still within the stencil life, it should be stored in a separate container and not returned to the original container with new fresh paste. The used paste should be properly identified and only used within the stencil life. Always adhere to that, because it may be 12 hours, it may be more depending on the formula. It depends on the paste. For instance, water soluble, it has a much shorter life than no cleans. And pushing paste on the stencil past the stencil life may cost you more in quality issues than the few dollars it costs of tossing exhausted pastes. Also, overloading the stencil with paste is counterproductive. Not only does all the paste get exposed to the environment, but it also may hinder the paste rolling or stick to your blade holders. So you want to maintain a pinky to a thumb size roll, or if you have skinny fingers, use a US dime to a quarter size roll. You want to add more paste as it's being used to maintain the supply, and it'll also freshen the paste as you use it. You can also, for a better option, is opt for a solder monitoring and paste dispensing system on your screen printer, because that will result in less waste and more control over your process. So next we're going to get into solder paste selection, but do we have any questions of what we covered so far?
Nothing in the chat box. Right, and for everyone's information, it is lower right corner, what looks like a little text window, square. Chat with everyone. That's where you go to place your messages if you wish.
Okay. So there are tons of vendors and formulations out there of solder paste. So how do you know you're using the best one? Well, if you ask the sales guy, they have the best. However, vendors have different formulas, different flavors of paste, and no two are going to perform exactly the same. Even within a company, if you have multiple sites, unless there is absolute control in maintaining the same environmental conditions, paste may perform differently depending on geography. You also have to consider if you have to ship paste to plants that are outside the country, or if they have local supply sources. Paste vendors, they're always working on the next generation of paste to address previous performance issues that come up, or for new technology or application methods. So the best paste that you had 5 years ago may not be the best paste that is out on the market today. So paste evaluations need to be conducted periodically, as painful as it can be, to take advantage of the latest improvements in technology. And when you do go to upgrade your paste, don't let cost or convenience be the factors that dictate your paste selection. You want to save the money on your quality gains and your improvements instead. So when you do decide that this is the time to benchmark and evaluate a new solder paste, it can seem insurmountable. So how do you go about doing the project? Well, first thing is that you need to consider all aspects of the process throughout the entire factory. SMT is not the only factor that you need to consider. But starting with SMT, you need to consider the paste performance on the line. What are the critical to quality characteristics, and how do you go about validating these things? I'm going to show you a few tables. This is part of a paste evaluation that was done through Chris Shea of Shea Engineering Services, and it breaks down the key characteristics, how to validate them to ensure that they meet the performance needs. As mentioned, cold slump, hot slump, stencil life, and tackiness are all the keys to performance in SMT. Once you get past SMT, you have to have consideration made for the flux residues if you're evaluating no clean fluxes and if the residues stay on the board. So you got to look at your testing. Do you ICT test? How does the flux perform during ICT or flying probe test? Can the pins penetrate the flux residues with ease, or does it get harder to probe these flux residues the longer the assembly sits between manufacturing and test? Fluxes are also known to change test readings over time, so that should be validated as well. And are the residues gummy or are they hard and shatter? Because this can cause excessive buildup on test probes, which may increase false calls at testing, as well as increase your PMs for cleaning your probe tips. Also, you need to consider the residues provided the working environment. Does the residue provide the environment for rapid dendritic growth under the right conditions? And when you do need to clean off this flux, can it be done with your current wash system and detergents? Are they compatible? And how hard is it to remove these fluxes from under low standoff parts? If it does remain, how fast will dendrites grow under the right conditions? And if you are applying other materials such as underfills, coatings, encapsulants, you also have to determine if they're compatible as well. The good news is that there is guidance and tools out there to help facilitate a complete solder paste evaluation. The SMTA test board and paste evaluation kit shown here is a tool set that helps determine which paste is best for your factory and your process. All the features needed to test printability and performance past reflow are designed into this board. I have the website here. It's www.sheasmt.com, SMT-board-files, to get the information. The complete kit has files and all the information to do your own paste evaluation with the built-in guidance, BOMs, CAD files, to design and perform a thorough and data-driven evaluation. Weighted and ranked scoring helps narrow down the factors that are most important to your factory, because every factory may have different requirements. Guidance and step-by-steps are included to streamline the evaluation process and also to minimize the impact that you have on the production line times. And additionally, the board helps support SMTA programs such as the workforce development and the student and young professionals, because 10% of the board cells goes to these programs. Thank you very much for participating in our first webinar in our Critical to Quality series. I know your time is valuable, and I hope you found this beneficial. Reminder, a short survey will be sent via email. Please keep an eye out for it. And for those of you that return the completed survey, will be entered into a drawing for a $25 Amazon gift card, just as our way of saying thank you. And our next webinar will take place in February, and it'll focus on the keys to success for stencils, squeegee blades, and supports in the printing process. So stay tuned for more information. Thank you very much for your time. This concludes the webinar. Do we have any final questions or discussion points?
This is an open-ended meeting. We don't have to end it at any particular time. If there's any open discussion you want to have, please unmute yourself and ask away. We can have a little roundtable discussion and see if we can help solve some problems or provide other solutions. Any thoughts about what you want included in the next webinars? Pain points for yourselves?
Mike, hello.
Yes, sir.
Thank you. I would like to maybe in the future talk about voids in the reflow process a little bit, if it's possible.
Okay.
Yes, we're going to be looking at pretty much every aspect in SMT, including reflow, and they will be covered in future webinars.
Oh, thank you.
Okay, well, I apologize for the little technical issue with my internet. Was luckily able to recover without too much delay. I do appreciate everybody's time and attention. And everybody, if nobody has any other questions, I thank you for your time.
Thank you as well. Appreciate your time.